Okay, let's continue talking about vocab in this video, but this time the emphasis is going to be on types of data. Whenever we're talking about types of data or data in general, we are usually starting with what's called a data set. A data set is simply a table of values, or you can think of it as just any kind of a display of information that's collected from a sample. So here I'm sharing with you a really small data set from a local 30K running race. This data set has the typical characteristics of a lot of data sets that you'll see in this class. We have individuals, those are the 5 runners. We have variables of interest, that's overall place, age, city, and finish time for those runners. And then we have the data itself, and the data are the values of the variables. And you'll notice that some of those values are numbers and some of them are words. And after watching this video, you'll be comfortable with how we can describe these variables and how we can describe these data in general. So let's first talk about qualitative data or qualitative variables. So qualitative variables are those that take on values that are words or descriptions or classifications. Examples of qualitative variables would be gender or hair color, or the answer to a yes-no question on a survey, or the answer to the Coke-Pepsi question on a survey, or the answer to the question of what city are you from on a survey. Notice that all of the values or responses to those questions, to hair color or yes, no, or Coke, Pepsi, or city, all of those are words or descriptions or classifications. And as a result, qualitative variables are many times also known as categorical variables, because it seems like the responses that we see within qualitative variables are often going into one category or another. Now, qualitative variables can be broken up into nominal variables or ordinal variables. Nominal variables, as the word implies, suggest that there is no natural ordering to the values within this variable column. And so we can think of things like city or gender or major or political affiliation. Think about major for a second. So there's different majors like math and English and science and art. And when I list out those majors, there's no natural or inherent way of ranking or ordering those things. And since there is no natural ordering, we would say that it is a nominal variable. Now, if it's not nominal, it's ordinal. And an ordinal variable is one where there is a natural ordering or a natural ranking kind of going on. Like if I say to you, I'm going to send out a survey and I want everybody to tell me what their last letter grade was in their previous math class. When I see letters like B and C and D, doesn't that give me a sense of ordering or ranking in the sense of it tells me a little bit of where your overall level of understanding might have been in that class? So qualitative are either nominal or ordinal. If it's not a qualitative variable, it's likely to be quantitative. Now, quantitative variables are numerical, and so they're often pretty easy to spot as being quantitative. But be careful, just because you see a number does not necessarily mean that it's going to be a quantitative variable. And I'll talk more about that in a second. But quantitative variables talk to us about how much we have of something, or it involves counts or measurements. So a classic example of a qualitative variable that people think is quantitative is zip code. So when I say to people, let's list out some zip codes, they say, okay, we've got 48105, 48104, 48103. Those are some different Ann Arbor zip codes. But those are numbers, but they don't tell us how many of something. They don't represent a count or a measurement. And one of the things that I also always tell people is, if you can't really do any math on it, if you can't compute an average with those numbers or something like that, then it really might not be a quantitative variable. And think about that with zip code. It would never make sense to take an average of different zip codes. So zip code is one of the few cases where you will see it's involving a number, but it's actually not a number. It's more of a categorization than anything. And so zip code would be a qualitative or a categorical variable. But most numbers that you're going to see in here will be quantitative data, quantitative variables. Now, quantitative variables are either discrete or continuous. They are discrete if you are restricted to whole numbers. For instance, if I surveyed you and said, How many kids are you hoping to have someday? I would get responses like 0 or 1 or 2 or 3 or 5 or who knows, maybe 10, but it's always going to be a whole number. If you are restricted to a whole number, it is discrete. How many houses are on the street where you live? Maybe there's 10, maybe there's 2, maybe there's 52, maybe there's 24 as I have here. So notice the answer to that question always involves being restricted to a whole number. How many students there are at a community college? It's got to be a whole number. And so if you are restricted to a whole number, it is discrete. If you are not restricted to a whole number, it is continuous. Time, height, distance to work are great examples of continuous variables. You are not restricted to a whole number when I ask you the question, how far is it for you to drive to work? Some people might say to me, oh, it's 10 miles, it's 15 miles, it's 2 miles. But a lot of times people would say, oh, it's 2.5 miles, or it's 3.25 miles, or it's 15.7 miles. If you are not restricted in answering your question, if you're not restricted to a whole number, then it is a continuous variable. It's continuous data. Okay, so let's do a little bit of practice here. Which are qualitative and which are quantitative? The number of patients admitted to a hospital on a given day. So it's a number, it's numerical. Your guess at this point should likely be quantitative because it is numerical, but again, just because it's a number doesn't make it quantitative. You also at some point could be interested in doing some math on, the number of patients admitted to a hospital on a given day. Maybe you would compute an average of that or something. So example A would be quantitative. The model of car last sold by a particular dealer. Thinking Ford, GM, Chrysler, Mercedes, all these different models. Those are word descriptions or they are classifications. And so this is a qualitative variable, or it would be, as I said earlier, categorical. The same with part C, the name of your favorite song. Definitely nothing numerical about your favorite song, and so you're probably leaning toward it being qualitative, and that would be exactly right, because there are many different word descriptions or classifications for describing or naming your favorite song. The seating capacity of an auditorium. Now, that's going to be a number, and again, you might be interested in computing an average of seating capacities of auditoriums across a certain region or something like that, and so this is a number that represents a count, a measurement, and you could do math on it. It is quantitative. Okay, which are nominal and which are ordinal? The names of streets in a town. Now, this is actually a trick question in a way, because the names of streets in a town can be nominal and they can be ordinal. And the reason they can be nominal is because you think of a lot of streets and there's just no natural ordering to the different names to those streets. But then you also think of like certain downtown streets or things like that, like First Street, Second Street, Third Street. There is a sense of ordering there. So I'm not going to give you an exact answer to this question. It would kind of be based upon the data as you're looking at it. So sometimes it's hard to even say what the best term is to describe the data when you're not looking at the data itself. So just keep that in mind. Most cases, I think names of streets would be nominal, but again, unless we're looking at the data itself, we really can't say that here. Movie ratings of G, PG, PG-13, and R. There's definitely a sense of ranking or ordering when you hear those ratings. It makes me think of what's appropriate for my kids to watch and things like that. The winners of the gold, silver, and bronze medals in an Olympic swimming competition. Yes, ordering is definitely significant here, and so I think that ordinal is the best way to describe this one. Okay, and then which are discrete and which are continuous? The number of female members of the U.S. House of Representatives. Well, it's got to be a whole number, and if it's got to be a whole number and you're restricted to that, then we describe it as discrete. The amount of water used by a household during a given month. Are you restricted to a whole number of gallons of water in a given month? No. Is the water company only going to round to the nearest whole number when they bill you? Absolutely not. They're going to bill you for every, tenth and hundredth and thousandth of however units, whatever units they use, they're going to get you for every single fractional amount that they can. They are not going to restrict it to a whole number. So the amount of water is definitely a continuous variable then. And in C, the number of stories in an apartment building, well, you can only have a whole number of stories, right? 1 story, 2 story, 5 stories, 10 stories. And since you are restricted to a whole number, this would be discrete. And then in D, a person's body temperature. Well, we know that a typical body temperature used to be about 98.6, and that was not a whole number. And when temperatures are taken, they are never taken and just presented as whole numbers. And so this one would also be continuous. So A was discrete, B was continuous, C was discrete, and D was continuous. So in the final video, what I'm going to do is walk through some more examples where we just put all of the vocab together from this entire module. So check that one out now.